Global nuclear energy has entered a mature phase of its development. Many reactors have worked through their planned life cycle. The time has come to decommission them. Of the more than 400 energy blocks of nuclear power plants operating in the world, 1/4 have already come to the end of their useful life cycle. In the coming years, the decommissioning of nuclear power plants will become all the more urgent. Regardless of how long their closing is postponed, their decommissioning will still have to be done. Decommissioning is associated with a number of socio-environmental, economic, technological, and moral problems. It is therefore critical that in the interest of the international community and of each nuclear nation, that this process be as transparent as possible. A timely and transparent for all planned decommissioning of nuclear reactors will help to avoid unnecessary costs and make the process safer. Ideally, each station will be disassembled to a greenfield stage with unlimited usage. Another option, the so-called brownfield, may involve existing buildings and facilities and their use for other purposes. Each country, as it proceeds to decommission its reactors, is looking for a way to solve social and technological problems. Study of international experience, its adaptation for each country, is an important task for those who are setting out on this path. It allows one to avoid mistakes and make the process more transparent, efficient, and less expensive, and therefore safer and more socially acceptable. The technology of decommissioning consists of the following steps: reactor shutdown, removing spent nuclear fuel, transfer of spent nuclear fuel to storage or safe disposal, decontamination and dismantling of equipment and facilities. The last working reactor at the nuclear power station Greifswald was stopped on the 18th of December, 1990. Closure of the VVER 440 reactors in Greifswald began after publication of a report on the state of the safety of the plant. The experts of the National Agency for Nuclear Safety identified not only design defects, but also serious deficiencies in the safety culture of plant personnel. Decommissioning and dismantling of the nuclear power plant blocks have been carried out by Energiewerk Nord, whose experts have developed production and technical documentation to carry out dismantling of nuclear power plant Greifswald and its predecessor, the Rheinsberg nuclear power plant. Currently, Greifswald and Rheinsberg are the biggest projects of decommissioning nuclear power plants in the world. In 1994, a new concept of decommissioning was developed, according to which the work could be carried out by the same engineers and staff who operated the station. Now, 95% of the work is carried out by former employees of the plant. When the first nuclear power plant was created, it was thought that when the time comes to close it, it would be advisable to wait 50 years until the time when many radionuclides will have decayed. And after that, it would be less expensive and safer to disassemble the structure and dismantle and bury the equipment with residual radioactivity. At the Greifswald nuclear power plant, after an analysis of options, it became clear that the decommissioning of units without a waiting period was justified both from an economic and social perspective. The dose impact during the process of decommissioning turned out to be lower than during the operation of the plant. Every day at the plant they unbolted, sawed, cut, dismantled, packed, and transported up to 25 tons of material. Special techniques were developed to disassemble parts of the reactor and the other radioactively contaminated equipment. Those parts of the reactor with the highest levels of contamination were cut under water. Water has very good barrier properties and enables radioactive decay. Manipulators control the cutting tools and move the cut structural elements to a station for packaging. Nearly 2,000 tons of material must be dismantled in this way. The Seimas of Lithuania passed a law on the decommissioning of the first unit of the Ignalina nuclear power plant. In February 2001, it adopted a program for its decommissioning. It identified the activities that must be completed within 2001-2004. In many countries, regular payments are made to a fund for decommissioning as soon as nuclear power plants begin to operate. The money in that fund accumulates during the period of operation of the station. In Lithuania, such a fund was set up only in 1993. Each year, the Finance Ministry of Lithuania reviews and approves the plan for decommissioning of Block 1 of Ignalina nuclear power plant. The plan contains a list of specific projects, schedules, responsible persons, costs, and sources of financing. The Lithuanian government decided that the Ignalina nuclear power plant was to be decommissioned by dismantling in the shorter term after closure. This path allowed work to proceed on decommissioning by nuclear power plant personnel well versed in its design and features. Today the plant has created a very large department for decommissioning. The first thing we did was to create a special project management team. We chose a Western company that had such experience. It was a consortium of 3 countries, the United Kingdom, Belgium, and Sweden. The group had 2 tasks: the development of the decommissioning project for the first and second blocks of the Ignalina nuclear power plant. As a result of this cooperation, the detailed experience of 3 countries with decommissioning was analyzed. We knew how to build well, launch a nuclear power plant, operate it, and now we are closing them. We are doing this for the first time. It's like a person's life. He is born, educated, grows up, marries, works, and dies. It's the same cycle with a nuclear power plant. On the 31st of December 2004, the first block was shut down. A new phase of the shutdown reactor had begun. It still contains nuclear fuel. It is essential to ensure safety, maintenance of the water and chemical system, ventilation, and radiation monitoring. The Government Agency for Control of Nuclear Safety, VATESI, monitors compliance with safety regulations at nuclear facilities and decides about issuing licenses. After removal of the spent fuel from the reactor, as well as the reactor spent fuel storage pool, where it is cooled by water, the energy block will be free of high-level waste. It will be the site not of nuclear danger, but of radioactive hazard. The energy block will have to go through a procedure of decontamination, cleaning, and then dismantling of equipment, with the exception of the reactor vessel. The Swedish Parliament back in the 1980s decided on the gradual closure of all nuclear power generation as a function of their life cycle. But the first and not the oldest Swedish nuclear power plant unit was shut down in 1991 at the station Barsebäck. The main reason for its closure was pressure from neighboring Denmark. The Danes, having refused to build a nuclear power plant on their own territory, could not reconcile this with the fact that on the other side of the strait, 19 kilometers from the Danish capital, was a Swedish nuclear power plant. On the 31st of May 2005, the second and last block of the Swedish station Barsebäck was closed. After the closure of the plant, all fuel assemblies were removed from the reactor core and placed in a temporary storage for spent nuclear fuel. After that, the plant was sealed. There will be a waiting period before completion of the work. Now the plant management believes that this will happen in 2017. For the time being, no location has been identified for receiving all of the waste generated during dismantling and final disposal of the spent nuclear fuel. In addition to the technological solutions, decommissioning requires taking care of solving social problems of those personnel who will lose their jobs with plant closure. This is one of the more important and challenging tasks. We can delineate the following parts of the social program of nuclear power plant decommissioning. 1. Retraining and new employment for workers from the decommissioned nuclear power plants. 2. Restructuring of the management of nuclear power plants through the transformation of certain divisions of the plants into independent enterprises. 3. Compensation and benefits to dismissed employees. And 4. Creation of alternative employment in new businesses in the town or city of the nuclear power plant. The closing of Greifswald nuclear power plant took place in a complex social political situation. The unification of Germany had just taken place. In Eastern Germany, industry had almost stopped since it could not compete with the Western German manufacturers. Unemployment grew. The government of unified Germany took active measures to mitigate the socio-economic impact of the closing of the station. The structure of the nuclear power plant included many support units, ranging from repair shops and ending with the cafeteria. Employees of the station, which closed overnight, were little prepared for the market economy. The number of employees at the time of the decision to close the nuclear power plant was 5,400. An enterprise management system with special projects was created in order to mitigate the social impacts. Programs were developed for the training and retraining of workers, as well as programs for layoffs and payment of benefits. After a plan for resolving the social problems was prepared, each plant worker knew whether he would continue to work at the plant or be dismissed. All employees of the company were divided into two groups, those who would still work at the plant and those who would be let go. The division was made according to the principle that those who would be able to find a job more readily would be dismissed more quickly, and those least prepared for finding new employment would be left at the plant. In order to determine which employee belonged to which category, a scoring system was developed. For example, for seniority, an employee received 2 points. For a child in the family, 4 points. For 2 children, 5 points. For 3 children, 6 points. For age, those over 45 received 2 points. For disability, 1 point. For marital status, 2 points. Those workers who obtained the lowest score were the first to be let go. As a result of this policy, during the first years after the closure, the nuclear power plant drastically reduced the number of employees under the age of 40. Social issues in the process of decommissioning of the Ignalina nuclear power plant proved more difficult to solve than technical problems. Indeed, the reduction of staff who built the station, operated the station, and then suddenly they began not to be needed. This was a difficult point. Here the problem was complicated by the fact that the city and the station are mutually dependent. Visaginas is home to nearly 100% of the employees of the Ignalina nuclear power plant. We combined efforts with the trade unions and invited our plant employees for recommendations. We initiated the development and adoption in Lithuania of the special law on social safeguards for personnel let go in connection with the closing of the nuclear power plant. Even before the adoption of the law, the plant administration signed an agreement with the plant's trade unions in which the stages of cooperation were described. We developed a strategy of social support personnel during the closure of Ignalina nuclear power plant. We decided to reorganize the plant, that is, we began on the basis of plant divisions to create independent companies. Their legal status was first state-owned and then publicly owned with stockholders and based on new contracts. As a result of the restructuring, 5 new companies emerged that are now working on their own. For Sweden, the social problem was not so relevant. Plant employees numbered about 400 to 500 people, and Sweden is not a large country. Those who lost their jobs at one plant could rather easily find them at another plant. Solving the problem of spent nuclear fuel and radioactive waste management is a very difficult systemic challenge. Our existing world experience does not provide for a guaranteed safe solution to this problem. At this stage of development, we can offer the following solutions. 1. Creating long-term storage of radioactive waste and spent nuclear fuel. 2. Sorting of waste by degree of contamination. 3. 3. Deployment of nuclear and radioactive waste in dry cask containers at the site of long-term storage. 4. Monitoring of the waste over an extended time and the search for socially and environmentally acceptable technologies for the reprocessing or disposal. On the territory of Greifswald Nuclear Power Plant, an interim storage site for isolation of all waste generated during the dismantling of Greifswald and Rheinsberg nuclear power plants has been built. Here is stored the spent nuclear fuel from both nuclear power plants. Its total storage capacity is 200,000 cubic meters. It meets the needs calculated for the total volume of waste resulting from the dismantling of Greifswald and Rheinsberg nuclear power plants. This space is used to store shipping container storage of type Koster, which contain spent nuclear fuel from the nuclear power plants. As you go through the halls of the interim storage facility, you can see the scale and the huge size of the complex. Over the course of the next decade, the facility will serve to house dismantled pieces, and for another 40 years will serve as the place of storage of the radioactive material. This is where the processing of what is delivered or of those materials already in storage takes place. As a result of these actions, space in the storage area can be economized. The whole complex is a highly efficient production and modern center for the disposal and processing of radioactive waste, which meets all specifications for this type of site. Over the entire history of the Ignalina nuclear power plant, no spent nuclear fuel nor other radioactive materials have ever been removed. Everything is stored in the current storage site. There was no plan for the dry storage of spent fuel from the RBMK reactor. Ignalina nuclear power plant became the first plant where a project had been undertaken for the storage of spent nuclear fuel in special containers. At the moment in Sweden, granite galleries at a depth of 150 meters are being constructed and filled with radioactive waste. The decision has been made to dispose of spent nuclear fuel at a depth of 500 meters. There are 2 alternative sites. The final choice of sites is taking place. After filling both storage sites, it is expected that they will be filled with rock and turned into repositories. For those residents of the cities and towns near decommissioning nuclear power plants, there are fears of social collapse and of what will happen after plant closure. How justified are these fears? Is it possible to breathe new life into cities and towns where nuclear power plants are closed? Here there was once a turbine hall of 1 kilometer length. After the dismantling of its equipment, a new production of components for shipbuilding and welding shop are planned. On the territory of the former nuclear power plant, a new natural gas-fired power plant is planned. Simultaneously with the dismantling of the station, the restructuring of the discharge canal into a modern industrial port took place. In 2003, on the day of the inauguration of the port, the schooner brig Greif was the first ship that came into the new port. Today, the industrial port has become a reality. After the end of dismantling work, the area will also be developed as an industrial and energy center. It will play an important role in the economy of Mecklenburg, northern Pomerania, but without a nuclear power plant. The decommissioning of the nuclear power plant represents a very large realm. In the area of Visaginas, the creation of an industrial park is planned on the site of the former base of construction which served the nuclear power plant. This technology park will manufacture high-tech equipment, including computer technology. No matter how the residents of Visaginas evaluate the closure of the nuclear power plant, they understand that a new approach is now needed and will require the same skill and responsibility as that of operation of the nuclear power plant. If we want the public to continue to recognize nuclear power, we have to show that public that we can not only build and operate nuclear power plants safely, but that we know how to close them safely. No one will fly on an airplane if it can only fly but not land. It's a simple principle. Participation in the planning of the decommissioning of nuclear power plant reactors by authorities at various levels, by the nuclear industry, and by the public can make the process acceptable to society. For example, in Germany, at the level of the government land, Mecklenburg-Vorpommern, a public council was established to discuss and inform the public about the problems encountered during the decommissioning of Greifswald nuclear power plant and possible ways to overcome them. The council has emerged as a tool to resolve conflicts that arise and for cooperation between participants in the process. He then discussed the following issues. Somehow the large buildings are not being cut up at our Rheinsberg and Lubmin nuclear power plants. Why not? They have a high level of radioactivity. But if they are now cut up, that radioactivity will be released. If they will be left for 40 more years anyway, let them be left there. After 20 years, it will become possible to cut them. We do not need extra risk. Decommissioning of nuclear power plants is an inevitable, natural, and necessary process in the life cycle of the nuclear power plant. Our accumulated world experience of decommissioning shows the need for a timely and transparent planning process. It is essential to be concerned about the safety not only in those sites where the nuclear power plants have operated, but also in those places where radioactive waste and spent nuclear fuel will be stored. We have no moral right to shift the burden of the problems associated with radioactive and nuclear waste onto the shoulders of future generations.